Okay, now we'll do this problem, right? Based on the function. Okay. Um, Suppose if a to b is onto function, if is one of the function a to b, right? A to b is onto and 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 gb another function b to c, right? B to c is onto, right? It's onto then so that then then so that then so that uh, so that the product of function, the combustion function, no, so that the product function, right? Product function, that means a composition function g composition f, right? G composition f a to c is onto, right? G composition a to c is onto, right? Right? G composition a to c is onto. Okay. Right? G composition a to c is onto. Right? Now will prove this part. Okay. Okay. Your claim is G combustion F is onto. Right? The claim is G combustion F is onto. Okay. Let you have this F A to B is onto. So okay. F A to B is onto. They are like this. Therefore, you take one of the element in the codomain. Therefore, let B belong to B. They are like this. A belong to A such that f of A equal B. Now your f of A belong to B, no? F of A belong to B. Uh, let suppose you take one of the element from here. Let C belong to capital C. There are like this, your f of A equal B, no? That's B belong to B. Right? You put f of A equal to B, right? Such that G of this element f of A, okay, G of f of A, we get C belong to C, therefore C. This one implies they are like this, f of A equal B belong to B such that, what is the meaning of this one? G composition f of A equal C. That means you take one of the element A belong to A, let C belong to C, they are like this, A belong to A such that G composition f of A equal C, that means it's called as a onto function. Okay. Therefore, G composition f is onto function. Okay. Very simple exercise. Suppose A and B are onto function, sorry, f and g are onto function. You want to show that this composition function also are onto function. Now we will do this problem. Right? We will do this problem. Now we will do this problem. F is one of the function. Let f is one of the function, real number to real number, defined by f of x equal, right, f of x equal s cube plus 5, so that f is bijective and hence find f inverse. So that f is bijective and hence find f inverse. Okay, hence find f inverse. Okay, first you want to show that f is bijective, therefore you want to show that f is one-to-one and one-to. Let f of x1 equal f of x2, you take s1 s2 belong to real number, then you will get x1 cube plus 5 s2 cube plus 5. This one implies s1 cube equal s2 cube. This one implies x1 equal s2. This means f is 1-to-1. Now you want to show that f is onto. For that, right? For that you take one of the element from here. By belong to real, choose your x value. How can use x value here? S cube plus 1 equal to y. Okay. Okay. You have some hint for this part, right? In this simple idea, here you have it. Okay. Choose x equal, right? Choose x equal. How can you choose x values? For that, for that, for that, Okay. Now choose x values, right? Choose x values. How can choose x values? That means x cube plus 5 equal y. Then s cube equal y minus 5. Then you get x equal y minus 5 to the power 1/3. Choose x equal this value, y minus 5 to the power 1/3. This can also belong to real number because y is real number, y minus 5 to the power 1/3 also real number. Now you want to show that f of x equal y. No, that means you take this f of now. F of x means f of x means your function is s cube plus 5. S cube means y minus 5 to the power 1/3 to the power cube plus 5 is y minus 5 is 3 cancel plus 5 you get y. That is for all you take y belong to real number. They are like this x equal y minus 5 to the power 1/3 belong to real such that f of x equal y. Therefore f is onto. Therefore f is 1 to 1 and onto. Therefore f is bijective. Okay, f is bijective. Okay, f is bijective. Suppose f is bijective means f is invertible. We already have some theorems. Therefore f is invertible. F is invertible mean f inverse exit. F inverse exit. Okay. Now you want to find the f inverse. For that you have this formula. You have f of x equal to y s cube plus 5. Right. Therefore x equal f inverse by, we already have this formula, f inverse by this value. F inverse y equal x, this value, y minus 5 to the power 1/3. Therefore, it is your f inverse. F inverse y equal y minus 5 to the power 1/3. Now we replace y by x. We get your f inverse formula, f inverse x minus 5 to the power 1/3. It is your inverse function. Okay, it is your inverse function. Now we will move to the next exercise, right? Next exercise. Okay, it's 3. F is a function, let f is a function r minus 3 to r minus 1 be defined by f of x equal x minus 2 x minus 3, so that f is invertible and hence find f inverse. So that f is invertible, so that f is bijective, and hence find f inverse. and hence find f inverse. Okay. Therefore, for a bijective, to take f of x1 equal f of x2 for all x1, x2 belong to R minus singleton 3. S does not take the value 3 because here, suppose it's 3, then it's not defined. Now you can put here in this function x1 minus 2, x1 minus 3, x2 minus 2, x2 minus 3. From this one, x1 minus 2, s2 minus 3, s2 minus 2, s1 minus 3. Now you can simplify this one, right? If you simplify this one, you will get minus x1 equal to minus x2. Therefore, x1 equal to s2. s1 equal to s2 means f is 1 to 1. Therefore, f is 1 to 1. Now for on to, right, now for on to condition, now for on to condition, let you take one of the element from the R, the codomain, let y belong to R minus codomain R minus singleton 1. Choose x values, right? You have some ideas. I already told you x minus 2, x minus 3, you put here y. Now this x minus 2 equal xy minus 3y. Suppose you get here 3y minus 2 over y minus 1 equal your x. Now choose x equal this value. 3y minus 2, y minus 1. This will also belong to R minus singleton 1. Right, R minus singleton 1. Right, R minus singleton 1. Now you want to show that f of x equal to y. Right. Now you take f of x equal formula x minus 2 over x minus 3. Suppose x value this one. 3y minus 2, y minus 1, minus 2. 3y minus 2, y minus 1, minus 1. 3y minus 2 minus 2y plus 2. 3y minus 2 minus y plus 1. 3y minus 5 means y. 2 cancel. Here, here 3, no? The function is 3. Yeah, 3. Therefore, you get here 3y plus 3. Then you get here 1. Y over 1. Y. Right? That is for all to take y belong to real minus Newton 1 such that they are like this to exist these values. 3y minus 2 over y minus 1 belong to R minus singleton 1. such that f of x equal y. Therefore, f is onto. F is 1 to 1 onto. Okay. Now you want to find the f inverse, right? F is 1 to 1 onto. Therefore, f is bijective. Therefore, f is invertible. Because if it's bijective, then if it's invertible, we have some theorem proofs. If it's invertible, now you want to confine the f inverse y, it is your x. What is the x value? X value is f inverse y, x equal 3y minus 2 over y minus 1. 3y minus 2 over y minus 1. It is your f inverse y, right? It is your f inverse y, y minus 1. Now we replace y by x. Then we get f inverse x equal 3x minus 2 over x minus 1. It is your required inverse function, right? 3y minus 2 over x minus 1. Now we replace y by x, then you can get the inverse function 3x minus 2 over x minus 1. Okay. Now we will do this problem. Right. Exercise 4. A function f is injective but not surjective. A function f is not f is injective. F is injective. That means f is 1 to 1. F is 1 to 1, but not f is injective but not surjective. But not surjective. Second part, a function f is not injective. A function f is not injective. F is not injective but surjective. Third part, a function f is neither injective nor surjective. F is neither injective nor surjective. Okay, this part you want to do now. Okay, a function f is injective but not surjective. Right. For this part, for the first part, you take one of the set S, take the element 1, 2, 3. You have y, take the elements 1, 2, 3, 4. Your function f is x to y defined by f of x equal to x. Therefore, f of 1 equal to 1, f of 2 equal to, f of 3 equal to 3. For all x belong to S. Therefore, it is obviously 1-to-1 function. Okay. It is domain. It is the codomain. Take the 1, 2, 3, 4. 1, 2, 3. Can assign 1, 1, 2, 2, 3, 3. Therefore, it is 1-to-1. Clearly true if f is 1-to-1. Right? Clearly. Therefore, f is 1-to-1. Okay. For all x belong to x. Now, what is the f of x? You want to show that f of x equal to y for onto condition. Suppose f of 1, 1, f of 1, sorry, John, your image f of 1, f of 2, f of 3, no? Here f of 1, 1, f of 2, 2, f of 3, 3. But this subset of y, not equal y, therefore f is not onto, because here there is no pre-image to f4. There is no pre-image, right? Pre-image for 4. Therefore f is not onto. There is no pre-image for f. There is no pre-image for f, therefore f is not onto. F is not onto means f is not surjective, but f is injective. Okay. For second part, f is not injective but surjective. For this part, second part, you take x1 of the set minus 1, 1, 2. Y in the set 1, comma 4. Now your f is x2y defined by f of x equal scared for all x belong to x. Okay, for all x belong to x. Therefore, it is not one-to-one. You want to show that f is not one-to-one but surjective. Why f is not one-to-one? You take f of minus 1, f of 1. Both are equal, no? Because minus 1, 1, plus 1, 1. Therefore, you can take this one, but minus 1 not equal to 1. Therefore, f is not one-to-one. Therefore, f is not one-to-one. For a surjective condition means you can take this image f of x, f of 1, sorry, f of minus 1, f of 1, f of 2. What is the value? F of minus 1, f of 1, both are equal 1. And f of 2 is 4, scared no 4. It is equal to y. Therefore, f is onto, but f is not one-to-one, right? F is onto, but f is not one-to-one. That is, a function is f is not injective, means f is not onto, but surjective. That one. Next part, the function f is neither injective nor surjective. That means the function is not one-to-one and onto. For that part, this part, you take x is one of the set 1, 2, 3, 4. By another set A, B, C, D. Right? Defined by f is x to y defined by f of 1, f of 2 both are A, and f of 3, f of 4 both are D. What happen? This function 1, 2, 3, 4. Here A, B, C, D. F of 1, f of 2 assigned to, what is the mapping? F of 1, f of 2 assigned to, right? F of 1, f of 2 assigned to f of A. 3, 4 assigned to D. Obviously, this is onto mapping, no? There is remaining elements here, B, C there in the pre-image, image. Therefore, if it's not onto. And one-to-one condition, suppose f of 1 equal f of 2, 1 not equal to 2. Therefore, if it's not one-to-one. Okay. You know, f of 1 equal, f of 2 equal A, no? They given 1. But 1 not equal to 2. Therefore, f is not one-to-one. Okay. F is not one-to-one. F is not one-to-one. We take the image also not equal, that's it, no? Because here, onto condition also not satisfying. Onto condition, your f of x equal f of 1, f of 2, f of 3, f of 4. Right. F of 1 means f of 1, f of 2, A. Both are A. F of 2, f of 3, B. But this subset of y, no? Because y consists element A, B, C, D. Not equal y. Equal y means onto, but here not subset of y. Therefore, f is not onto, because there is no pre-image to these elements. any all elements have the pre-image, then you consider if it's one onto mapping. Here, there is no pre-image to become a C. Therefore, it is not a onto function. Okay. Therefore, in this case, function is neither one-to-one and onto. Okay. Functions neither one-to-one and onto. Okay. Next question. Next question. Six. Let A comma let A be subset of X, and if it's a function X to Y be a function, then show that you want to show that there are 4 conditions. First one, A subset of B implies f of A subset of f of B. Second condition, f of A union B equal f of A union f of B. Third condition, f of A intersection B subset of f of A intersection f of B by means of an example, by means of example, right, means of example, so that the equality does not hold in general. The equality does not hold in general. Fourth part, f of A minus B subset of f of A minus f of B. Right. This part we want to prove now. Okay. First part, let you take one of the element y belong to f of A. Okay. Then you can write y equal f of x for some x belong to A. Is it okay? For some x belong to A. You can find such element for S set, it means S belong to A, then you can write y equal to f of x. Yeah, for y equal f of x, here for some x belong to A, now for some x belong to B, because A subset of B. Therefore, x belong to B, then you can write y belong to f of B. Assume that y belong to f of A, we prove y belong to f of B, therefore f of A subset of f of B. Second part, let you take y belong to f of A union B. Right, f of A union B. Then you can write y equal f of x for some x belong to A union B. Okay, x belong to A union B. This one implies y equal to f of x, right, for some x belong to A or x belong to B. Okay, x belong to A or x belong to B. Now you can write this one equal to y equal to f of x for some x belong to a, or right, y equal f of x for some x belong to b, right? Y belong to f of x for some x belong to a means, right, this y belong to f of a, or here y belong to similarly f of b. So implies y belong to f of a union f of b, right? The converse part also true. Converse part also true. Okay, converse part also true. Otherwise, okay, no problem. Otherwise, you can take like this. You can keep this one. Otherwise, okay, x belong to f of a union f of b. Okay, therefore, first you take y belong to f of a. Now we prove y belong to f of a union f of b. Therefore, f of a union b subset of f of a union f of b. First condition. Okay, f of a union b, f of a union f of b. Now since a subset a union b and b subset of union b. Now you take both. Suppose a subset of b means from the previous part you will write f of a subset of f of a union b and f of b subset of f of a union b from the first part. From this both you will write f of a union f of b subset of f of a union b. This is your second part. 1 and 2 implies equality whole. That means f of a union b equal f of a union f of b. Okay, f of a union b, f of a union f of b. Okay. Now for the third part you want to give the count example also. For reverse part does not work. Therefore you want to give the count example. Okay. Let you take y belong to f of a intersection b. Then you will write y equal f of x for some x belong to a intersection b. Okay, from this part y equal f of x for some x belong to a and x belong to b. Now we will write y equal f of x for some x belong to a and again y equal f of x for some x belong to b. And now it is symbolized y belong to x belong to a, no? Y belong to f of a and y belong to f of b. We already know that. That's right. Y belong to f of a intersection f of b. That is f of a intersection b subset of f of a intersection f of b. Now count example. For reverse part does not hold, you will take one of the function f integer number to integer number, right? Defined by f of x equal squared for all x belong to set. If you take one of the set A, 1, 2. You take another set B, -1, 3. Okay. What about the f of a? F of a means 1, comma 4, no? Similarly, f of b means 1, comma 9. What is the intersection of f of a intersection f of b? What is the value? Here singleton 1. Okay. Now, what is the a intersection b? A intersection b. A intersection b means there is for a and b there is no common element. Therefore, it's empty set. No, it is empty set. Therefore, f of a intersection b, f of a intersection b means that one also empty, right? That one also empty set. Therefore, f of a intersection f of b does not equal a intersection b. But it is not called. Therefore, for any element of x is not subset of that one, right? Therefore, this one not work, right? Subset of work. Therefore, equal does not true. Okay, only subset is true. Equal does not true. Okay, equal does not true. Now, last part, right? The last part, you want to do this question, right? F of a minus b equal, sorry, f of a minus f of b subset of f of a minus b. What part? You want to show that f of a minus f of b subset of this one, subset of this one. F of a minus b. Let y belong to this set. F of a minus f of b. This one implies y belong to f of a and y does not belong to f of b. This one implies y equal f of x for some x belong to a and y equal f of x, then you will write for some x does not belong to b, no? X does not belong to b. This one means y equal f of x for some x belong to a and x does not belong to b means for some x belong to a minus b. This one means y equal f of x, but x for some x belong to a minus b. X belong to a minus b, then we will write y belong to f of a minus b. That is f of a minus f of b subset of f of a minus b, right? F of a minus f of b subset of f of a minus b. Okay. Okay. Now we'll stop, right? Then we'll continue the next lectures.